HVAC 360 is brought to you today by the Sweet But Sweaty Corporation. Today we're introducing our latest product, the Mug Mop. Don't let this summer heat turn your face into looking like a melted candle. Grab the Mug Mop and regain your respect. Complete with an ergonomic handle and antimicrobial pine-scented fabric, just wipe your mug and wring the mop out in the included belt-mounted mini mop bucket. One quick pull of the bucket lever and you'll be ready to wipe your face again. Mother Nature never stood a chance. Sweat stops with the Mug Mop. Hey everybody, welcome back. Matt Nelson here, your host for HVAC 360, helping you be the best and the brightest in the field of HVAC. Each week, I'm either sharing information and lessons learned from the field or talking with industry experts. This week, we're going to actually take a question that I was posed, or that was posed to me, and that question is, if there is a 10-foot rule between the outside air and the exhaust air, why don't pieces of manufactured equipment have to follow that same rule? All right. I'm going to start this episode off because we're going to be talking a lot about code. I'm going to be starting it off with a disclaimer. Obviously, this is not engineering advice. This is merely a educational experience for you. You're going to have to do your own work. This is a valuable skill that you're going to have to develop over time. You can't rely on anybody, not even me, telling you exactly what the code interpretation that you are engineering to. I'm just trying to help you kind of go through what my process is. I'll show it to you, and we can actually see if we can't answer this question. Having said that, let's get into the research. All right, so the first thing we want to do is we want to look at what is in this question. What can help us out? We know that, for instance, this 10-foot rule is provided to us by code. So whether it's 10 feet here, it's some metric amount in some other countries, Canada, Australia, UK. It's gonna be something, and they probably have similar codes elsewhere. But for the most part, I'm going to be talking about U.S. codes. So when I talk about U.S. codes, I'm going to reference the International Code Council. So the International Code Council mechanical code for most states is going to be adopted in some form or fashion. They might make certain amendments. They might make certain changes. They might even, at a local level, if your municipality is big enough, they might have specific things that they're going to add or subtract to it. This is very specific. And again, this is why I put the disclaimer in the front of the show. You're going to have to do your own homework. But again, this is homework that is it's kind of fun to go back and forth and find out exactly what you can learn from analyzing this and reaching your own conclusions. So typically, what I found is the International Code Council, the mechanical codes for most states are available online. You can view them. It's not something that you necessarily have to go out and purchase. So if you want to do this at home and play along, grab your laptop, look up the International Mechanical Code, and we'll go from there. So there are two sections that, when we look at the International Mechanical Code, there's going to be two sections that, when we look down the list of chapters that are included in the International Mechanical Code, that are going to just pop out at us right away. There's going to be Chapter 4, which covers ventilation, and Chapter 5, which covers exhaust systems. So, again, when you were looking at this and we're going through the codes, this is one of those essential skills as a designer that you're going to want to have. Even if you're a contractor, it might not be a bad idea to be able to know exactly how to go through code language, code books. Some of the language might be a little bit, obtuse. I use a difficult word to explain that things might be difficult to understand. That's really good. Thanks, Matt. It's better to know how to go through the codes than blindly following supervisors and things like that. people, your higher-ups. You need to be able to know this information for yourself. And if it's different from what they're telling you, it's a good opportunity to have a great in-depth discussion about why they feel that way. Why did they say this when the code says something else? They might not have realized that the codes change, and that's the thing. Codes change all the time, and it's really important that you keep up on the latest code cycle. A lot of this stuff, the 10-foot rule has been around for a long time, so a lot of them don't really change that much. But when they make those subtle changes, you should be aware of them because, it can throw you off, and you're ultimately responsible for your own designs. So, having said that, codes change, and it's important to know that you really need to keep all your sets of codes. I know that when I was growing up as an engineer, one of my duties was when the latest changes to the code came out, they'd give me the sheets and they'd have me replace certain sheets that were updated. Now, I couldn't just throw the old sheets away, even though that's kind of what I thought, but it's important not to throw those sheets away. It's important to keep what changes were made in what year, so you could reference that. That would be kind of a cover sheet. And then you'd keep all the pages that you changed out after that. That's really important because if you have a design, say, for instance, a building that you were working on had a problem, but it was designed under the 2013 code, and you looked under the current code and it said something different, and you're like, well, wait a minute. Why did they do it like this? Well, you can't look at the current code for something that was built in 2013. It was built under that code, so it had to follow those rules. So you go back and you look at the 2013 code and see what had changed, what applied, and if it made sense for that. So you really need to keep all that information kind of going forward as you're designing. You just can't throw it away. It's essential for some code reference. All right. So again, we're looking at the two chapters. Chapter 4 covers ventilation. Now, when I talk about ventilation, I really mean outside air. That's an easy equation. They talk about, and it's so important because words really matter here. Ventilation means something very specific to in the code language. So, of course, it means outside air, but it also kind of has a certain nuance about it. So, it's really important to know that each one of these words you can actually look up, go back, and kind of figure out and identify. And that's some of the things that help you understand the different parts of the code. So when required, that's in 401.3. It's basically you want to ventilate a space when it's occupied. Really, if it's not occupied, you don't have to ventilate a space. It doesn't need any outside air. So it's interesting just to see the code actually spelling that out. When nobody's there, you don't need to ventilate it. You don't need to put any outside air into that space. Now, if you're not familiar with it, there's two methods of actually going about and ventilating a space. You can either do natural ventilation or you can do mechanical ventilation. Now, the natural ventilation, those include things like windows, doors, louvers, really anything to the outside that is readily accessible by the occupants. It's what they control. So an operable window, they can go and open the window and get ventilation air, and that would fall under natural ventilation. Mechanical ventilation is, on the other hand, is going to be some mechanical system that's going to use a fan to move air from one point to another. So they differentiate those two pieces. We're going to be focusing more on the mechanical ventilation and the intakes regarding that. Speaking about that, you go to the next section, 401.4, and that talks about intake openings. Now, there's really four different categories that the intake openings fall into, and this is kind of like where to locate the intake openings. So the first one is you want to make sure it's 10 feet from lot lines and other buildings. Okay, well, that really doesn't address our question, but it's interesting enough. Number two is it has to be at least 10 feet horizontally from hazardous or noxious sources. So this is other vents alleyways, loading docks, things like that. They go through a specific list. And again, it's so important to know exactly what you're calling or what you're looking at, because if it doesn't fall in that category, then you have your engineering judgment to say, hey, it's not listed like that. Here's the intent that I think it is, and this is the way I'm interpreting the code. So you can have your engineering opinion on this. So if it's less than 10 feet horizontally from one of these noxious, hazardous sources, it has to be 25 feet above those. So that is the stipulation for number 2. Number 3 is that if it's 3 feet or more below a contamination source. Now, that's the very important key there, contamination source. Then it has to be, if it's 3 or more feet below, then it can be within 10 feet. So basically, if your outside air is underneath your exhaust area or your noxious contamination source area, then you have to be 3 feet below, but you can be within that 10 feet. If it's on the kind of the same line, you can be 10 feet away again, but that 3 feet below allows you some separation. I assume that they're going to figure that the noxious fumes are going to go up. They're going to be more buoyant, so everything's going up. So I think that's why they allow that particular exception to or rule to be followed. And the number 4 is some flood zone requirement. So I'm not going to include that in this discussion. But again, all the words matter. Specifically, and if you didn't know this, specifically, if it's not described within that section, there actually is a chapter called definitions. So if you're unclear about any of these words and what they exactly mean in the code, you can go up to the definitions section, the definitions chapter, and take a look at that. Now, the first one, obviously looking to answer this question, the contamination sources, that really kind of identified exactly, what I'd be looking for. So contamination sources is important. So I put a pin in that, and I looked up some of the other things. Ventilation. Ventilation actually, per the definitions, is a portion of the supply air that comes from the outside. So again, easy answer. It's outside air, but it's a portion of the supply air. Exhaust systems are ducts and assemblies, all their different openings and stuff like that take air from the space and exhaust it directly to the outdoors. So again, the ventilation exhaust system, the ducts and assemblies. And what the important thing that I pulled away from the exhaust system is that it seems like it's not part of, there might be a fan included, but it doesn't really say that it's being exhausted to a piece of equipment. It seems almost separate. And I think that, in combination with these contamination sources, really supplies some sort of information that we could dig into a little bit further. So it happens that contamination sources has its own little paragraph, and I'm going to read that to you now. It's 401.6, contamination sources. So stationary local sources producing airborne particles, heat, odors, fumes, spray, vapors, smoke, or gases in such quantities as to be irritating or injurious to health shall be provided with an exhaust system according to Chapter 5. So, obviously, spray, vapors, fumes, again, those noxious things that are really objectionable, that are injurious to health, that are irritating. Those are kind of, when I'm thinking engineering-wise, those are going to be pretty important. I guess when I think about it, if you were to sit outside of air handling unit where the relief was or the exhaust was, and you were to sit there all day and just breathe in that exhaust, it probably wouldn't bother you. It probably wouldn't irritate you. It probably wouldn't injure you at all. So that was one of the things. And I think, again, it's important maybe to redefine what we classify on an air handling unit. And this is just specifically for an air handling unit. that your outside air intake and your exhaust, maybe the exhaust is the wrong word. Per code, maybe that's the wrong word to use because it doesn't really fall into that category of, producing all these, odors, fumes, etc. Because, ultimately, you're going to be, returning a portion of what you're bringing back. You're going to return a portion of that, and the rest is going to be relieved. You're going to have this, you're going to bring in outside air. It has to be a zero balance. So there's amount of outside air, and the amount of relief air should be equal if you're keeping just kind of a neutral air balance. So the return air comes back, and that's obviously not noxious because you could use it if the conditions were right. You just reuse it. But you have to bring in some outside air just to kind of, dilute and provide ventilation for the spaces because they don't have, you're providing mechanical ventilation in this case. So to keep the air balance neutral, you got to get rid of some of the air. And I think calling that air that you get rid of exhaust may be a little bit of a, you're doing yourself a disservice by naming it that. Maybe relief is a better word for that. And again, using relief doesn't trigger the exhaust connotation. So, that being said, for air handling units, I think relief is the right word to use. So for air handling units, if you have your relief and your outside air intake close to together, I don't think that's a big deal. I don't think that's a huge deal, and I think that generally speaking, that would satisfy the code. So to answer part of the question, that's okay. So, but we don't want to necessarily stop. We want to be able to analyze the entire code. We don't want to have to go through and just analyze a particular, just one of the chapters. You want to make sure that you can go to both of the chapters, read through it, and just have a complete understanding of what you're going to make your decision based on. So we look to chapter 5. So we go to chapter 5 now, and we look at the exhaust. Now, I think it's important that we understand what is the independent, what the exhaust system is. So on 501.2, independent systems required. So this is where it's required. Single or combined mechanical exhaust systems for environmental air shall be independent of all other exhaust systems. Okay, that's curious. What does that mean? Dryer exhaust shall be independent of all their systems. Type 1 exhaust systems shall be independent. Type 2 exhaust systems for food processing operation shall be independent. Kitchen exhaust and things like that. So again, you talk about things that might have noxious. If you had to stand in front of a fume or a fume hood or a food exhaust fan, that might be, objectionable. The smells, you might have, the grease-laden air that might affect you. All those things could affect you. So it's important to understand exactly what that is. So now you look into a little bit further about the location of the outlets. So what are they talking about? And especially, again, it's key. What are they talking about? What are they talking about when they're talking about exhaust outlets? So the location of the exhaust outlets, number one, they're talking about something that's explosive or flammable vapors. Okay, that is not what we're talking about here. We're not talking about explosive or flammable vapors, so that we cross that off. We talk about product conveying exhaust, product conveying outlets. And again, what exactly that is, I'm not sure, but I think they're talking about lighter than air particles. They're talking about dust. They're talking about different things that contain, actual physical material that could be breathed in and, again, be harmful, noxious, injurious to your health. And whether I'm saying injurious right, I'm not sure. I'm an engineer. I'm not an English major. All right. So now we get to step 3. Step 3 actually has a bunch of what we're talking about because it says for all environmental exhaust. Okay, that's pretty all-inclusive. You have to be 3 feet from a property line, 3 feet above an operable window. Again, that's the same thing that we heard about before. And it needs to be 10 feet from any mechanical fresh air intake. Okay, that's fine. So such exhaust systems shall not be, and this is listed in, such exhaust systems shall not be considered hazardous or noxious. Okay, so when they put these guidelines in for 3 feet, 3 feet, 10 feet, again, they're not hazardous, they're not noxious. They wanted to reiterate that fact because they already covered explosive and flammable. They already covered product conveying. They wanted to make sure this is not considered hazardous or noxious. And again, that's getting back to that, contamination sources kind of definition. Number 4, they have the floodplain, and then 5, they have specific sections that have more information for different systems like subslab soil exhaust systems, smoke control systems, refrigerant discharge, closed dryer exhaust. Those all have specific requirements that are found elsewhere in the code. So the one thing that really did bother me was that when we talk about the different systems, so the scope of the exhaust in 501.1, they talk about some of the mechanical exhausts, closed dryers, cooking appliances, hazardous exhaust systems, dust, stock, refuse conveyor systems, subslab soil exhaust systems, smoke control. And then this one thing hit me, and I was like, okay, I was so sure and so certain. They said energy recovery ventilation systems. I'm like, what? I'm like, what? Where? What? I didn't get it. I'm like, why are they linking, energy recovery ventilation systems in with the rest of them? And really, it seems when we take a look at it, and again, they have their own section on, these different systems. So if we go down to, what is it? 515. We'll find that these energy recovery systems, again, where they're required by the energy code, are gonna have to follow some of the things. Again, it seems that the intent here is to not have them. They're prohibited from a lot of the different systems, unless it's just solely a sensible heat coil type heat exchanger where there's no possibility of cross contamination. So ultimately, and I think the one thing we have to understand is that ERVs come in a couple different flavors. They come in indoor flavors and outdoor flavors. The indoor flavors, obviously, you are going to have them ducted. So the ducts are going to be, when it's separate from the piece of equipment, when you have a duct that's going to be an exhaust duct, that has to follow those same rules. So if it's a ERV with an exhaust duct and it goes through the roof, it has to follow those same rules as applies to everything else. But if it's an outdoor unit and you have the relief and you have the outside air, I think, or the exhaust and the outside air rather, because you're not necessarily relieving anything, you're exhausting everything for the energy recovery wheel. The whole purpose of it. I think that is where you really have to start using your engineering judgment. You have to know exactly what you're exhausting. And you have to know, is this going to be hazardous? Could you stand out there all day and breathe it in and not be affected? What is coming through there? Is it simply just general air from the space that you're just trying to get some heat recovery on because you have to get rid of it to get a neutral air balance in the space? Is it going to be an exhaust system that is coming from toilet rooms? Is that going to have a particular odor? Because they do list odors as one of those things, in addition to vapors, fumes, all that. Odors. Is it going to be objectionable? Is it going to be strong? You certainly don't want that being re-entrained in your ventilation system, and that's part of what they say is that you don't want to have it be entrained in the air. All right. So my answer to this question: do they have to follow the same rules? And I would say, in my engineering adjustment, if it's an air handling unit, no, because it's not a valid contamination source. Your relief air is not a valid contamination source. If it's an ERV, if it's something where you're taking toilet exhaust or a large amount of toilet exhaust, there's some ERVs that I know that when you take a look at the calculations, they say, okay, let's limit the toilet exhaust to 10%. Now you have some dilution factor before you exhaust it. That, I think, is valid. I think that anybody supplying a rooftop ERV is going to have some sort of understanding of this exhaust is going to be directed in a certain direction, and they're going to be pulling outside air in a different direction. Usually, when you take a look at those ERV units, a lot of times it's around the corner. Curiously enough, I thought about that, and I'm like, is there something about a corner that becomes magical? Like if it's taking outside air through the back end of the unit, and on the side you have the exhaust for the ERV. I couldn't find anything relating to the corners. Anything that I did find was still, about that 3 foot mark, but there was nothing specifically saying, okay, you know what, it has to be 3 feet in either direction, from the corner. But I didn't necessarily find anything that was concrete that I would be, willing to base an engineering judgment on. So, obviously, you want to put a big asterisk here. No, I don't think that the equipment has to follow that, especially when the contamination sources are not, what's listed in Chapter 4. But in the same regard, you still have to be intelligent about your design. You still have to be intelligent about where you're placing your equipment. Should you line up an outside air intake with a relief from an adjacent unit? No, I don't think that's wise, engineering-wise. I think you'd still want to keep that separation, just because it makes sense, just because it may be a little best practice. I mean, there are clear things that you need to identify, and you want to make sure that they don't necessarily line up. I'd be a little bit more careful when you're doing an energy recovery unit on the roof, because it is a little bit of a gray area. I'd keep things away from that exhaust side. But I don't see anything concrete, forbidding it. And again, I would hang my hat on that contamination source type of verbiage. Obviously, it's one thing when you're dealing with all your own stuff, exhausts, outside air intakes for a mechanical engineer, when you're going through the design, but I'd always put a word of caution. Remember, there are other people working on the building. Don't forget about things like the emergency generator exhaust. You don't want to forget about plumbing vents and things that the plumbing engineer might design into the project. You have to be aware of all those different possible sources of noxious and hazardous contaminants, and you have to account for that in your design. All right, so that's my answer to the question. Does rooftop equipment have to comply with that 10-foot rule? So I hope that was helpful. That is by no means definitive in the code. It's not directly addressed, but I hope this kind of takes you through the process of, finding the chapters that are relevant. You kind of go through, read through each chapter. Some chapters apply, some chapters don't, or some paragraphs apply and some paragraphs don't. And you have to kind of go through the whole process for yourself. And again, I would encourage you to kind of go through. I've highlighted some of those. It should be roughly the same, Chapter 4, Chapter 5. Take a look at that. And I'd encourage you to go through it yourself. If this is something, if you're a designer, if you're new to design, I'd encourage you to go through that exercise, because again, it's going to be one of those skills that you're going to have to use over and over again. And, things change. So keep up on the codes. Make sure you know how to do it. Make sure that you're aware when the code changes. All right, thanks so much for listening. I hope you learned something here. If you're looking, if you know somebody who's looking for information about this or who's newer to, being a designer, you might want to share this episode, and I really appreciate that if you pass this along. If you're not a subscriber, go over to HVAC360.com and join the growing community of people just like you. And lastly, I'd be honored if anybody considered leaving me a rating and review on Apple Podcasts. That helps everybody out. Trying to get this information out to people. If you're on YouTube, jump over there, HVAC360.com or HVAC360, look that up and subscribe to my YouTube channel. Again, that helps me do some special things in the future if we get enough people signed up to do that. All right, well, that's it for this episode of HVAC 360. I'm Matt Nelson, helping you be the best and the brightest in the field of HVAC. And as always, know what you build and share what you know.